Okay, so now we're just going to do more practice of evaluating limits, both numerically and graphically. Again, I just want to emphasize the notation for one-sided limits. This is the limit as x goes to c from the left. This is the limit as x goes to c from the right. A limit only exists if the limit as x goes to c from the left is the same as the limit as x goes to c from the right. Great. There is a formal definition for limits. It is in the book. Read it if you want. It makes the limit sound way more confusing than it is. It is a formal definition, though. So it's kind of like dressing formal, you know. It's a little bit more work, but sometimes it's appropriate. All right, I want you to find the limit as x goes to 2 of 3x plus 2. Pause the video, unpause when you're ready to check. Go. All right, hopefully you got that the limit was 8. Again, if we look at the calculator, so I put this into y equals 3x plus 2. I went to my table, and I can see that as I approach 2 from the left, the numbers get really close to 8. As I approach 2 from the right, the numbers get really close to 8. In fact, the function equals 8 when x is 2. You will start to notice, hopefully, that that's going to be what we are going to start to call direct substitution. It's going to be a little bit easier way to solve a limit if it applies. It doesn't always apply. But in this case, that's one way we could have evaluated the limit, is just plug in 2. 3 times 2 plus 2, we get 8. Next one. Alright, so here we're given this graph. We are going to assume that this continues on, and this continues on. Notice that's an open circle, that's an open circle. So here you have to evaluate the limits graphically, since you are only given a graph. So I want you to pause the video, evaluate these limits, unpause when you're ready to check, and discuss all of these fun answers. Okay, so the limit as x goes to -4. Well, this is a double-sided limit, which is a standard limit. So I want to look right here at -4. The function exists, and it is continuous, and I can see that the y value is -3, so the limit is -3. What is the limit as x goes to -4 from the left? If the limit as x goes to -4 is -3, this had to be -3. The limit as x goes to 0. So that's going to be right here. I can see that as I approach an x value of 0 from the left and from the right, the function is -1. The limit is -1. What is the limit as x goes to -3? -3, it does not exist on the function, but that doesn't mean the limit doesn't. However, in this case, the function doesn't even exist to the right of -3 at all. Like, there's nothing here. There's just a gap in the domain. Therefore, the limit is not going to exist. A one-sided limit will, and we can see that right here. The limit as x goes to -3 from the left is, if I'm on this piece and I go down towards -3, going, boom, -4. I don't actually get there. The function doesn't exist, but the limit does, because I am approaching -4 as x is approaching -3 from the left. The limit as x goes to 1, that's going to be right here. That's 0. And again, I have to look from both sides. So as I approach from the left and as I approach from the right, I approach a height of 0. The limit as x goes to -1 does not exist for the same reason as it didn't exist at -3. So the function doesn't even exist just to the left of -1. So I only could do a one-sided limit here. And I can see that right here. The limit as x goes to -1 from the right is going to be 0. So although the function doesn't exist at -1, the limit is still going to be 0 as I approach from the right. And here that gets me to the next question. What is the value of the function at -1? So remember, this is not a limit now. This is actually asking me to evaluate the function, which means when x is -1, what is the y value? Y value doesn't exist. When x is -4, what is the y value? The y value is -3. There we go. Alright, it's really important that we understand the concept of a limit. Don't overthink it. What are you approaching? What y value or height are you approaching as you approach a given x value? Thank you.